boundaries. Worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
Alright, what's up everybody? NY Gamers, hello. What's up, New York Gamers? You're the one that needed help with the Regents test? I know that's like a big thing that people in New York take. They take the Regents exam. It's like their determiner of like whether you get to go to like awesome, cool high school or something, right? Anyways, yeah, today is Tuesday. Was the first day I did not have to go into campus at UCLA to go teach. Pretty interesting shift of things. Students took the final exam yesterday. I am gonna have to go into campus tomorrow to go pick up the remaining exams that some of them took at one of the, I don't know, it's called like accessible education testing centers or something. And then I got to give it to my TA, and then we got to start grading. 182 exams I got to grade. Maybe more, honestly. What's up, Kazuki? Good to see you.
My man!
Anyways, yeah. So that's all the news on my end. Oh, yeah, Nick got back to me. And from Wibbly, right, with the education challenge, and he gave me the list of names who completed it and how many entries they have. So tomorrow during the stream I'll do the giveaway for the different prizes we have. So I'll make an announcement on the Discord, but yeah, come on by the stream tomorrow if you participated in Nick's cool geometry teaching experiment. We're gonna give out probably, I don't know, $50-$60 worth of prizes. What's up, Shantrix? Yeah. Trying to think of anything else is special today. No, it's just another day in paradise. I mean, the riots are kind of like the protests are chilling out a little bit. I think luckily cooler heads are prevailing and we're not getting too crazy here in LA. So it's one of my friends' birthdays. We're gonna go out and celebrate dinner with him tonight. And I think what else? No, I think that's it. I know school year's wrapping up for some people. The Marines were sent there. Yeah, the Marines were sent yesterday, but today, just from like what I'm seeing on my local TikTok and Instagram and stuff, it doesn't look like the protests aren't getting worse. And by worse, I mean like they're not like burning more things, and like the police aren't detaining more people. I know, and it's hard to tell like what's true anymore, because you know Trump will say like, oh, we deployed 2,000 Marines, and then you know the state of California will be like, well, technically you only sent 300. So it's all just big dick swinging. That's all it really is, man. Again, I agree that, yeah, legally they have a right to remove people who are here illegally. That, like, whatever, cool. Yeah, I guess we have laws. I'm cool with laws. But it's the way they're doing it. They just want to make a big fucking shit show out of it. You know, they're going to Home Depots. They're going to school graduations. They're going to, you know, places of work. And they're making a big spectacle out of it in order just to piss people off. That's why it's fucked. again, I have nothing wrong with, you know, following the law and, like, you know, whatever, deporting people that aren't here, whatever, legally, sure. I think you should provide ways for people to stay here legally, you know, but it's the way they're doing it, which is provoking a response, and it's all just for fucking politics and posturing. That's all it is. The only reason they're doing it the way they're doing it is to get, like, some sort of response. Yeah, something they can put on the news. It's pretty dumb. They're removing legal people without due process. No, I don't think they're... No, I don't think they're removing citizens. When they start removing citizens, that's when everything is fucked. They're removing non-citizens without due process, which is, like, you know... This is where things get, like, technically kind of murky, because the Constitution says that everyone is entitled to due process, but then people are like, is that people in the land, or is that only citizens? So... I don't know. It's a little iffy. In all reality, it's just Trump just being a dick, and he's just trying to see what he can get away with. He's just over there just, like, he's so happy to see the news talking about him, and he's so happy to be, like, you know, pissing off the snowflakes or whatever. It's dumb. And it sucks, though, because, like, it's affecting real people's lives. Like, you got, like, kids who are here, and they're born, so they're legally citizens because of birthright, and, like, their mom or dad's getting fucking, like, shipped off. Because in some cases... in San Antonio, they were doing things where they, you know, the courts were sending out text messages being like, hey, come to court so we can resolve your asylum application, you know. Like, these people, like, trying to go through the legal ways of staying in the country. And when they got there, it was basically entrapment, because the court just instantly dismissed their asylum claim, just immediately. And then after they got out of court, ICE was waiting there to just put them on a fucking bus and just, like, ship them out, which is fucked up. I don't bait people who are trying to do the right thing. Now nobody's gonna show up to their fucking court hearings. What's up, Equity? I got my 8th grade grad awards tomorrow, so I got no classes. Nice, dude. Congrats on... what awards are you getting, NY Gamers? Technically, I wouldn't know if you're a citizen or not. Well, no, they check to make sure you're a citizen first. I mean, yeah, the due process is they're not going through all the legal hearings, because you have a lot of you can do a lot of things like asylum claiming and whatnot. There's a lot of, like, weird legal things to try and stay in the country. I don't think I've heard any cases of them deporting citizens. Once they start doing that, then we've lost the plot, and then you'll see me on the streets as well. Right now, I'm just like, I don't know. It's I know they just want a response. They just... What's the benefit for removing illegal immigrants? Don't they do the jobs that Americans think they are too good for? What's the reason for... Well, so, okay. There's the argument they make that if you have illegal immigrants, they put stresses on the public services that are provided, which are supposed to be reserved for citizens. So that includes, like, healthcare, right? Once you guys get old enough and you have to start paying for healthcare, you're gonna realize your fucking health insurance is expensive, and it sucks. Why it's so expensive, and the reason it is so expensive, in one part, the main part is that the whole industry is fucked up, and drug companies are terrible, and hospitals are greedy. But also another big part is that when people go into a hospital, they can't refuse to treat you because you don't have insurance. So if you go in with a broken leg and then get treated, and then they say, okay, man, here's the bill, it's like $5,000, you know, because we helped you, and then you say, oh, well, I don't have health insurance, or I'm not a legal citizen, so, like, you can't really come after me. That bill gets then passed off to other people who pay insurance, or it gets passed off to the state. That's one of the arguments they make. Then they make the argument that, oh, well, they don't pay taxes, and that's wrong, because illegal immigrants do pay taxes. They pay a ton of taxes, and a lot of times they don't get, again, the Social Security. They don't get the benefits that would come with paying taxes. But I think, in my mind, it comes down to that you do need a nation with, like, controlled borders. Once you don't have borders anymore, you no longer have a nation. So I do agree that there should be some check on, like, people coming in and out of the country, because everybody wants to come to the U.S. And if you left it completely open, this place would go downhill pretty quick. You have to have some sort of control on things, and so that's the issue. They do take I don't say I wouldn't say they take jobs from people, because you're right. They are a lot of times the people that are working in the fields. They're picking up, you know, tomatoes and lettuce, like whatever. Like they do a lot of jobs that I don't think people say they're too good for, but like they would not do for the same price. This is also an issue I have with, you know, it's one thing to arrest like illegal immigrants who are working in, you know, fields and whatnot. They should be arresting the fucking owners, because all it really is semi-legal slavery, because these people that own these farms and whatnot and are employing illegal immigrants, they're not paying them the amount that they would pay like a legal immigrant. It's usually, they know they can get away with giving them, you know, shit money. They know they can get away with like abusing them. They know they can get away with, oh, if an illegal immigrant gets hurt at my workplace, I don't have to worry about it because he's not going to sue me because then he would expose that he's here illegally. So they really should also be coming after these contractors, these farm owners, these people that employ illegal immigrants and basically exploit them. That's fucked. So yeah. Well, not just citizens, even people who legally live in the country without a green card are getting removed. Well, no, you need a green card to legally live in the country. No, you know, you need some sort of visa or papers or something. We have rules. I mean, Shantrix, you're from Canada, right? Canada's experiencing this issue. I'm sure you see it with immigration, right? There's probably some tensions going on because I think they let like a fuck ton of people in from India, right? I mean, you're probably directly part of this, and you can see how that starts to cause like some issues in society. You need to have like control on like people coming in and out at like, you know, controlled rates. Otherwise, everything kind of goes to shit. We need laws. Do you fuck with Playboy Cardi? Yeah, Playboy Cardi's dope. He's a cool guy. Yeah, there are other ways for temporary residents. Yeah, there are visas and stuff. But again, it's temporary. And I agree that they're starting to revoke a lot of those a lot quicker for kind of some bullshit reasons. Like if you speak out against Israel or you speak out, you know, in other things that don't follow the agenda of what the current administration likes, yeah, they will revoke your temporary residence visa stuff. So I don't agree with that. But also, yeah, don't. If you went to another country and you started protesting and doing shit and like in their eyes causing trouble, they would just fucking kick you out. They don't care. We're almost like too nice sometimes with things. Yeah. Anyways, can they revoke a green card? Yeah. I mean, they can choose not to renew it, or they can choose to. If you apply for citizenship, they can just like deny it. Yeah. I think until you're like a full citizen, at least at this point in time, that's the only way you're like fully protected. Otherwise, everything is, you know, in process. Land of the free, yeah. Land of the free for those that pay for it, I guess. I don't know. Rah. Okay, here. You guys got some good questions. Yeah, sorry. I apologize for the ranting, but you know, it's current events happening today. It's important to talk about things. But let's help you guys out with some math and science. All right, cool. All right, welcome everyone to Office Hours. My name is Dr. Phil's Actual Education. Streaming helps you with math homework, science homework.
Yeah.
Chemistry too, right? We do all those stuff. Yeah. Got some good questions. 1K, you got the first question of the day. This looks like physics. All right, let's see. Do I fuck with Bayesian statistics? Like Bayes' law? I can do Bayes' law's questions. Yeah. Yeah, Shantrix, the issue is that like the definition of committing a crime is very like vague. They can make up anything that like you technically if you get a speeding ticket, you committed a crime, you know. That's dumb. Yeah. Okay, the hare is sleeping. Oh, this is the tortoise and the hare. Do you guys know about the tortoise and the hare? Is that still a thing they like read to you guys as like children? Is that a story? It's a cool little moral, right? It's like, just keep going even if you're slow. Like, something wins the race. Perseverance wins the race. I forget. Okay. A hare is sleeping 1,200 meters. Let's draw some stuff. There we go. Thank you, Jeff. Slow and steady. Dude, I have a fucking stroke today trying to remember that. Thank you. Okay. All right. Let's say this is the finish line, right? All right. Cool. I'm gonna draw like a checkered flag because I think it's cool. There you go. Look at that. That's a beautiful checkered flag. Okay. From a location that's the story I know is the hare is tasty. I do like rabbit or mutton. Is that what they call it? Mutton? What's the difference between rabbit and mutton? Okay, and there is a rabbit here. Trying to draw a rabbit. Yeah, that's like kind of a rabbit. We're really testing my artistic skills today. I draw like a bunny nose. Okay, whatever. There's our rabbit. Mutton is goat? Oh, it's lamb. Oh, my bad. I fucked up. It's a faster rabbit. That rabbit has no legs. Okay, fine. Here, we'll add some legs to it, too. All right. Is that better? Is that good? I think it's a pretty decent fucking rabbit I drew. Right? Let's, like, fix the legs a little bit. We're going to have an office hours stream where, like, it's just Dr. Gold does paint or something. Where does it lay eggs? I'm kind of seeing why the rabbit lost the race. It's a giant poop rabbit. Okay. It's the best rabbit I could come up with. Okay. The tortoise passes him at a steady rate of 5 centimeters per second. Okay. So we have the tortoise. You guys want to see my tortoise drawing skills? I think this is a pretty good tortoise. Y'all be nice to me. That's an ellipse. He's got wheelie feet. He's got wheelie feet, guys. It's okay. Wheelie feet. Okay, here's the tortoise. At a steady speed. Okay, first of all, 1K. Anytime you see shit given in centimeters, convert that shit to meters. We don't want to deal with centimeters. Everything's in meters, kilograms, and whatever. So here, we'll say the velocity of this is equal to 0.05 meters per second. Okay. If the hare finally wakes up 6.5 hours later, then what minimum acceleration must he have in order to pass the tortoise before the finish line? Okay, very cool. Is it a continent tortoise? Okay. So, yes. Okay, first of all, hours is also not good. We don't like hours. So I'm going to say that 6.5 hours. And we're going to multiply that by 3,600 seconds per hour. So, here, let me get my calculator out. $23,400, Jeff says. Okay, probably. Sounds about right. $23,400. Cool. All right, cool. right, so let's try to determine where the turtle is after the 6.5 hours, okay? So here, at t is equal to 6.5 hours, we can figure out how far this thing has gone from our kinematics equation, which says that x is equal to x naught plus v naught t plus 1/2 at squared. Now, a steady speed. Steady speed means that velocity is constant, okay? This means, so here we go, say steady speed equals constant velocity. So that means that acceleration is equal to 0, all right? So we can get rid of this. All right, we're going to say he starts at 0. Okay. Oh, your dad works on the math that makes tires efficient? That's super cool. Tires are dope. Expensive. Okay. Okay. So then if we plug in our V naught here, which is 0.05, times the 23,400, we should get a number of meters, right? And here, we're going to get that this is equal to, I mean, I guess like 1150. Oh, 1170. Okay, cool. All right. So once he's gotten here, oh, that's cool. Throw them on the treadmill. What do you mean the treadmill? Did you see if they roll or like what? What is the treadmill test? Okay. So at this point, well here, let's move the tortoise over a little bit more. Tortoise is like right here. Tortoise is like almost 1. This is going to be at, yes, he's 30 meters. 30 meters from the finish line. Okay. So here's a good question. Okay. So he's only 30 meters away. So what we can do is calculate how much more time he's going to need in order to finish and make sure that the rabbit can cover that 1200 in that same amount of time. Okay. So, what I can do here, right, is I can just say, okay, well, distance is equal to velocity times time. So 30 meters is equal to 0.05 times the time, divide by 0.05, divide by 0.05. And so I think we're going to get like 600 seconds, right? Yeah, 600 seconds. So t equals 600 seconds. So that's how much time the tortoise needs to now finish the race. And that's how much time this rabbit here has to run the full 1200. All right, night, poison mouse. Okay. Good night, dog. Okay, so now we can say, so this was for the tortoise. Okay, so for the rabbit, we can say needs to run 1200 meters in 600 seconds with some sort of acceleration. I'm a mouse. Are you a dormouse? What type of mouse are you? Okay, so for the rabbit, we can say that, again, x equals x naught plus v naught t plus 1/2 at squared. So the final position needs to be 1200. Your initial position is 0. Your initial velocity is 0. We assume the rabbit starts at rest. And then we have plus 1/2 a. We're going to solve for the acceleration. And then we have time. Time has to be 600 seconds squared. Okay. So this is going to be 1200. This is going to be, what is that, 36,000? 36 with 4 zeros. No, 360,000. Right? 600 squared. Yeah, 360,000, and then times 1/2. So that's gonna be 180,000 times A. So here's the cool thing. When I divide this by this, I can just start chopping some zeros off. Let's chop these zeros off. Chop 2 here. I'm gonna chop 2 here. So now I'm gonna have that 12 over 180 or 1800. Okay, this isn't too bad actually. That's actually a really, really slow acceleration. Did I convert meters per second? I think I did, right? Because the tortoise goes at 5 centimeters per second, so that's 0.05 meters per second. Right? That's the right answer, though. That is. Yeah, it's just really small, but okay, sure. Yeah, so you get 0.006 repeating, and then that's going to be meters per second squared. That's a very small acceleration. I mean, I guess it makes sense because the rabbit gets 10 fucking minutes to do about half a mile, or a little bit more than half a mile. What's the rabbit speed when he crosses the... Yeah, what's up, Shreya? What is the rabbit speed when he crosses the finish line? That's a good question. We could do that using this equation. This is a little bonus thing, if you wanted to know this. It's a good question. So V is equal to V naught plus AT. This is 0. So we're going to have our A, which is 0.0067 times 600. Yeah, let's see if this feasibly makes sense. This is probably a really fast rabbit. So we do this times 600. Oh, not bad. Jeff, that's not bad. 4 meters per second. Totally we do. I believe a rabbit could run at 4 meters per second. That's like 12 miles an hour. I mean, we could ask this, right? You know. What's the top speed of a rabbit? A European rabbit, by the way, can move at 25 miles per hour. So, and then I think 25 miles per hour to meters per second. I want to say that's close to 12. Yeah, 11.1. Yeah. You need help on bio? Okay, cool. You know where to submit the questions, dude. We'll do them. Greetings! What's up, Zach? Good to see you, man. Shout out to Zach. Zachy boy. What a realistic math problem. This is innovation for teachers. Yeah, I know. Yeah, sometimes you would solve this and you'd get like a really wacky number. But yeah, okay, cool. So not too bad. All right, cool. Does this make sense? To you, 1K? Let me download a PNG of it. You're just getting used to the formulas? Yeah. So, I mean, as you can see, right, this is a very important formula that shows up a lot, right? We're going to use this formula for a lot of things. And then this is another really important one. There's only 3 you have to know. And if you want to, if you want to see something cool, they're actually derivable from calculus. Here, let me put this in for 1K real quick. I guess this is physics. Yeah, so here, let's look at something really cool. Let's take the original definition. I don't get how you can convert meters per second to seconds. What did I do wrong? Meters per second to seconds. I don't get how you can convert meters per seconds to seconds. Well, okay, here we did 6.5 hours to seconds by doing 6.5 times 3600. The other thing was here. So they gave us a velocity which was 5 centimeters per second. And so that's that per second. Yeah, sorry, this is hours. Sorry, this is not meters per second. No, sorry, this is hours. It's the writing. Oh no, my handwriting. I think my handwriting's okay. It could be better though. So, quick little thing. If you want to see something interesting here, 1K. Let's remember what we know acceleration to be, right? This is acceleration. No, he's like, but I have to stay up to watch the physics. Okay, acceleration. This is all calculus. It's actually very cool how this works. So, acceleration is equal to the change in velocity over the change in time, right? We learned this in like really basic first kinematics physics lesson, okay? It turns out you can rewrite this in terms of a derivative. So instead of change in velocity over change in time, I could call this dv dt. This is a calculus thing you'll learn eventually. So acceleration is the same thing as dv dt. Now, if we have acceleration is equal to dv dt, I can take this dt here, and I can throw it over here on the left. So let's say we have this, okay? So now I have ADT is equal to dv, and what I can do is I can integrate both sides, all right? And what that's going to get me is that this is going to become a times t is equal to v, and then this is plus c. So you just rotate the triangle 90 degrees clockwise to derive the formula. Yeah. Now here's a cool thing. So this c, so this is when we do like, we call it like indefinite integral because I haven't defined my bounds. In order to figure out c, you need what's called like a boundary condition. Okay, so boundary condition. And what I can know for a boundary condition, right, is that at t is equal to 0, v is equal to v naught, right? V is equal to the initial velocity, right? So if we were to plug that into here to solve for c, right? Now I would get a times 0 is equal to v plus c. And then this also needs to equal... So now v is equal to v naught. This goes away. And what you get is that c is equal to negative v naught. All right, if I move that over, I get c equals minus v naught. So now, in my expression here, I can say that a times t is equal to v minus v naught. And you should notice that this is one of my physics equations that I already learned, right? Because if I add v naught to both sides, I get v is equal to v naught plus at. Remember, this is like one of the kinematics equations you have? Yeah. Here, we can go. Let's go find those kinematics equations real quick. And I want these. Well, this is like, where's like, I want stuff with x's and x naughts. Everyone has like a different little formula they use for it. Like x final. Okay, whatever. Yeah, this is like the Suvat. All right, now you're going to bed? He's actually going to bed now. Okay. But notice, right? Yeah, this is the same equation we got, right? V is equal to V naught plus AT, V equals to V naught A plus AT. And we got that strictly from the definition of acceleration being the derivative of velocity with respect to time. Now, I can take this further, all right? Because I know, so I can say now, I know that velocity is equal to dx dt. So dx dt is equal to v naught plus at. Okay. Again, let's move the dt over here on this side. You get that dx is equal to v naught plus at dt. And then we can integrate both sides. This gets me x plus c is equal to, the integral of v naught dt is v naught t. And the integral of at is raise the power divided by the new power. So that becomes t squared over 2. So this becomes plus 1/2 at squared. And now we come up with a new definition here, right? Which is that another boundary condition. Or I think they call it like initial condition sometimes, which is that at t equals 0, x equals x naught. This is the initial position. Okay, so when I plug in here, I'm going to get x naught plus c is equal to 0, 0. So that tells me c is equal to negative x naught. And now what we're left with is that x minus x naught is equal to v naught t plus 1/2 at squared. This is sometimes called just delta x because it's final position minus initial position. And then here's your third kinematics equation, right? Which came from here. So isn't that dope? I think that's like really cool. That using calculus, you can derive all of these equations from a very simple a equals dv dt. That's all you need to do. I think it's sick. Anyways. Cool. Good question, 1K. I appreciate the physics.
Well done! Well done!
Shantrick says, did the equations come first or did the calculus come first, though? Well, I mean, that's a good question. So, I mean, technically these rules have been around forever in our universe. I mean, this is just how the world works. But I think calculus was developed by Newton. Newton created calculus because he needed a new type of math to come up with these equations. So I believe calculus came first, and then calculus was used to derive these equations. All like new equations in physics, they aren't really like handed down like Moses got handed the tablets or some shit. Like they come from deriving things using math. So if you want to be discovering new things in physics, like new equations and whatnot, it really helps to have a good solid background in math. Because math is like the tool that allows us to do useful things in real life. That's why, you know, I tell students, anytime they're learning math and stuff, they're like, when am I ever going to use this? I say, well, you don't know when you're going to use it yet, but in these other classes and stuff, math is like the backbone for figuring out new stuff and like coming up with new discoveries. So learn math, do it. Okay. Let's see. Next question comes from Shantrix. You sent me? What'd you send? I don't see it, Jaden. Biology. Yeah, so okay, let me see what his biology question is. Okay, let's see this one real quick. So math is the pickaxe and physics equations are like the diamond ores. Yeah. Where's that one? I see it, Jaden. It's this, right? Yeah. This is the never give up meme. This is the classic one people always talk about. Wait, can these ads go away? Jesus Christ. What? Okay, there we go. Yeah. This is like the never give up because like you were so close to the diamonds. They make all sorts of memes about it. Anyways. Shane says, "Can I speak?" Yeah, you can speak, dude. Yeah, so I don't know. Biology is one of these things where, at least for the intro classes, you don't really need a tutor. You just need to like remember facts. It's dumb. I don't really like it because there's not a lot of thinking. There's not a lot of thinking involved in like early biology. It's just memorization, which is
because I have exam.
okay. Because you have an exam, yeah. So, you know, I can help you like answer these, but this is just like usually it's just like it's just looking things up. That's all it is. Like there's not really like there's no solving of the question, you know? Like when they say like which of the following statements is incorrect about an enzyme, like there's not an equation or a technique that I'm going to teach you that helps you answer this. You have to just memorize what the fuck an enzyme is and like what it isn't. Like I know that enzymes act as catalysts. So catalysts lower activation energy. That's correct. I know that enzymes speed up a chemical reaction because they're also a catalyst. Decrease in mass at the end of the chemical reaction. I don't know about that. I feel like that's false. I don't think catalysts lose mass.
Wait.
Catalysts do not lose mass during a chemical reaction. Yeah, okay. So this one is wrong.
What is catalyst?
What is a catalyst? See, now this is chemistry. Now we're actually doing math. Okay, so if you have a reaction, okay? Let's say you have a reaction that looks something like this, okay? This is usually called like energy. I don't know. Is this called like time or something? But usually in order to get from the beginning of a reaction to the end of a reaction, you have to go over a hill here. And this right here is what is called EA, which is also called the activation energy. Okay?
Is this like physics?
No, this is chemistry. I mean, it could be physics, but it's mainly chemistry. So in order
activation energy.
Activation energy is like the cost for you to do something. EA Sports. Yeah, true. It's in the game. So, for instance, if you want to burn something, let's say you want to burn, I don't know, I think methane. I think this is methane. Like C6H12O6. Let's say you want to burn methane, right? You have to add oxygen to it. And then that ends up giving you like water and CO2. Okay? But in order for this reaction to happen, okay, you need to like input heat. Okay? Like you need a certain amount of energy. Like you need a lighter, right? You need something to start this reaction. And that energy required to start it is called the activation energy. Nice. All right? Wow, thanks for the follow, dude. So what a catalyst does is a catalyst kind of gives you like a shortcut, and it lowers the activation energy. So this, for instance, would be a catalyst. Okay? It's something that decreases the amount of energy you need to do a reaction. Like it decreases the cost. Think of it like it's like a coupon. You know, if you want to go on a ride or you want to go like buy dinner or something, there's a cost to that, right? You got to pay money. A catalyst would be like a coupon that like discounts the amount of money you need to spend in order to do the thing.
Oh. Okay. That's like a coupon.
Yeah, catalyst is like a coupon. If you want to think it's like a coupon.
So how does enzyme act as catalyst?
Enzyme is a catalyst. Enzyme is a catalyst. Enzyme is a type of catalyst.
How?
It's an organic catalyst. How does it? I mean,
what
like
organic.
Organic means like made out of life shit, you know, made out of like skin, bones, blood, nature stuff. Organic means, I think, made from nature. Is that what organic means? Yeah. Yeah.
So.
Yeah. One sec. Let me answer this chat question real quick. Alexander says, "Hey, I'm learning calculus on my own to be ahead." Hey, good for you, man. And I had a question regarding L'Hopital's rule. I saw an exercise where you apply L'Hopital rules to a limit, and then you apply a rule, what you get from it, and then you do it like 4 times. Yeah. Is there a way to know ahead of time how many times you're going to have to apply L'Hopital's rule? Not particularly, although you can usually look at the exponent, is what you can usually do. So, just real quick, and then Jaden, I'll get right back to your question, just so I can answer this question for him real quick. But in general, if you're trying to do L'Hopital's rule and you got like x to the third over x to the fourth, you're going to need to do this like 3 times. Because you eventually need this. You need this derivative to eventually become 1, and then it's going to be like 1 over x. And then this will be like 1 over infinity, which is equal to 0.
But you can minus the division means minus.
100%. You could have also just done this as 1 over x like from the beginning. Like you could also simplify, and then you only got to do L'Hopital's rule once. But sometimes things don't look this nice. Sometimes it's like x cubed plus x squared, and this is plus like x to the first. Like this is you can't just simplify shit here. But the highest power here and the highest power here, basically you just need to reduce this thing down to a number, and then you can leave this as a variable, because when that's infinity, you're dividing by infinity. So that's kind of a basic rule of how many times you need to do it. Your teachers mean if they make you do it more than 3 times. But if you want a shortcut, the shortcut to doing these types of questions, Alejandros, is always just divide everything by the highest power of x. So if you had this as your question and they asked you to figure out what the limit was as x approaches 0 or infinity, sorry, what you could do is you could divide everything by x to the 4th. This is the highest power of x. So divide by x to the 4th, 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 right? Then this would become 1 over x plus 1 over x squared over, and this would be 1 plus 1 over x to the 3rd. And now when you take the limit as x approaches infinity, this is 0, this is 0, this is 0, and you just get 0 or 1. Now you only have to do it once. So this is a shortcut you can sometimes take to like cut out the amount of times you need to do L'Hopital's. If you have an example question, Alexandra, that you want me to go through, we have a website down there, actualdiscord.com/submit. You can submit whatever. I don't care. Anything math or science related. You have a homework question that was difficult, I'll go over the stream here live if you want. That's what Jaden's doing right here with his question. He uploaded this screenshot, and I'm helping him out with biology. But yeah, feel free to use it. Okay, Jaden, let's get back to your question. So, okay, thank you, Shantrix. So, yeah, Jeff says organic means containing carbon. Oh, interesting. Is that really what it is? I don't know if that's the exact way it is. Yeah.
But enzyme is not in carbon, right? Not inside the carbon, right?
I wonder if organic means it has to contain carbon. Let me see. Let's Google that real quick.
Yep.
Yes, Jeff's right. Organic is something that contains carbon. Yeah. So
enzyme got carbon inside.
Yeah, so like here's some example. So sugar, which is like sucrose, that contains carbon. DNA, which is amino acids, methane, CH4, ethanol. These are organic compounds. Well, now this is interesting because a diamond does contain carbon. Why is that not organic? Interesting. Table salt, sodium chloride, is not organic. Okay. I don't know. There's some.
So sucrose, what does sucrose do?
Is pencil lead organic? Yeah, I don't think so. Sucrose is organic. Yeah, I guess. Yeah, I agree with that.
What is sucrose again? What is sucrose?
What is sucrose? Sucrose is it's sugar, basically, is what it is.
Oh,
here.
shoot.
Yeah, that's what sucrose is. Okay.
Test. I need to read what
Yeah. Okay. So the key thing is that a catalyst does not decrease in mass at the end of a chemical reaction. How a catalyst works, or how an enzyme works. Let's see. Usually, what they do is they increase, I think, the activation site. So yeah, here we go.
oh, it's like lock and key.
Yeah, this is cool. So, yeah, a substrate is like two things that are trying to like react and like do shit to each other, okay? And the enzyme like provides a nice space for them to do it. You could think about like, let's say you're trying to cook an omelet, right?
Yeah.
A couple ways you could cook an omelet, right? I could take an egg and I could throw it on the sidewalk, and I could hope that the sidewalk gets hot enough, right, for it to cook. Yeah, but that would take a lot of time, right? Something that would make this easier, right, would be if I had a full kitchen, like a kitchen with like a stove and stuff, right? So that's kind of what an enzyme is. An enzyme provides a nice location for the reaction to occur so that it doesn't require as much effort for it to happen.
Okay.
Yeah. Does that make sense?
I still don't understand. You draw it out for me.
Well, I mean, this is it. Yeah, this is the drawing.
But I don't understand.
You don't understand. Okay. All right, let's see. What's up, Reki? We're learning biology. Okay. So, this right here, this is the enzyme, okay? Enzyme, yeah? Okay.
Yeah.
What the enzyme does, and let's say this thing right here, this is the reaction, okay? This reaction wants to happen between these two things. But it takes a lot of energy for that reaction to happen. What the enzyme does is it provides like a stable place for that reaction to happen. Do you see how this like locks in like a key? Like a key just like fits like a puzzle piece?
Lock and key.
Good, okay.
Lock and key.
So when it does that, it allows for this reaction to occur and like split into two different products using less energy.
Yeah.
It's like a stable base, and it reduces the amount of energy needed for this reaction to happen. Okay. So that's why enzymes help speed up chemical reactions. It's why they lower the activation energy. It's also what allows reactions to happen at low temperatures. Because when things are cold, things don't move as quickly. Like, things don't want to bump into each other. Reactions don't really want to happen. So, in order for things to happen at low temperatures, you need to have an enzyme that lowers the amount of energy you need. Okay? Because activation energy here, right? The amount of energy you need in order for something to happen, this is usually related to heat. Okay?
Yeah.
So, when it's cold, it's difficult to get over the hill.
Why is it difficult?
It just is. It's just difficult to get over the hill. You just don't have enough energy. Like, temperature is energy.
Oh, yeah.
Heat is energy. So when things are cold, you don't have a lot of energy to get over the hill. Okay?
Okay.
And so the key thing here was that, like, so this enzyme, when it helps out this reaction, it doesn't lose any mass.
Yeah.
Like, the enzyme doesn't get used up. So the statement here that an enzyme will decrease in mass at the end, this is wrong. And they wanted to know which thing was incorrect. Okay?
Okay.
All right, cool. All right. Which of the following enzymes is used to digest proteins in the stomach? This is just looking this up. I actually have no clue what this is, but I'm gonna guess it's pepsin. Enzymes in the stomach. Is it? Well, let's just see. Yeah, the primary digestive enzyme in the stomach is pepsin. Cool.
What's
You just
pepsin?
I don't know what the fuck pepsin is. You just look it up. Like, that's just something. This is the part of biology
I'll
where
just Google it.
you just Google it. You just look it up. Yeah. I mean, this I could at least explain to you in terms of like some chemistry and some cool stuff. This is just, did you memorize it on a note card? It's dumb. If you want to remember that, do you know what like Pepsid AC is? Have you heard of this Pepsid AC?
No.
So it's like a tablet that people take when they have like stomach problems. So maybe that would like help you remember pepsin.
Pepsin.
Yeah.
Wait, pepsin is the chief Wait, can I share my screen here? No.
Yes, pepsin is the chief digestive enzyme. Yeah, we went over that. I saw it. Okay. All right, let's see. Amylase only acts on starches, but not on proteins and fats. This statement shows that enzymes are... Well, not all proteins. That doesn't make any sense. Very efficient? Yeah, sure, but that has nothing to do with the statement. I think this is... I think it's one of these choices. So it says amylase only acts on starches, but it doesn't act on proteins or fats. So I want to say it's C, sensitive to the type of molecules, or it may be D, very specific to their action. Very specific in their action? That's just kind of weird. I don't know. That's a toss-up, man. I think it's C. Because this is saying that like amylase is picky. It only acts on certain things. It doesn't act on proteins or fats. It only acts on starch. Starch is like carbs. Carbs are starch. Yeah.
So, okay, okay, so what is... So it's like monosaccharides and disaccharides.
Those are sugars.
Those are sugars.
What are sugars? Usually carbon and hydrogen, I think. I think those are sugars are. They're like energy. There's like a chemistry thing to it, but a lot of this stuff, man, is really just like looking shit up. Like if you want to know like a polysaccharide is. Poly means many. Yeah, there you go. Cool. Yeah, starch is a polysaccharide. It means it has a bunch of different saccharides. A monosaccharide only has one saccharide. Like monosaccharide. Here are monosaccharides.
Okay.
So monosaccharides are like individual rings of things like glucose, fructose, or in this case galactose. Polysaccharides is putting a bunch of those things together. So
Okay.
in this case, right, starch is a bunch of these saccharides together. Cellulose is a bunch of these together. Glycogen is a bunch of these together with like these like things on the side.
I sent you on office hours like this, right?
Yeah, I see your notes.
this
Yeah, that's notes. That's cool. Yeah, I mean,
So
yeah, cool. These are things that you should know. Yeah, look, monosaccharides are simple. Disaccharides are doubles. So like glucose and glucose makes maltose. Glucose and fructose makes sucrose. This is like, I think what sugar is. Sugar is sucrose.
okay.
And then, cool, lactose, that's what's in like milk. Milk has lactose in it.
What is complex carbohydrates?
This just means lots of carbohydrate means CHO, like amounts of carbon, hydrogen, and oxygen. And so a polysaccharide has a bunch of those things, right? Like here, right? You see how this was a polysaccharide? Has a bunch of them together.
Yep.
Yeah.
Yep.
Cool.
It's mix of biochemistry.
Yeah, I mean this is like biochem. Yeah, because you're learning about like amino groups. This is acetate. Yeah. Twice as many H's as
I'm
O's.
learning, but
Yeah. Yeah, you just gotta read this shit. You just gotta read it, dude. I mean, I'm happy to explain, like, kind of the fun parts of it. Like, again, the activation energy thing was fun. Like, I like explaining how an enzyme works and, like why this does what this does.
activation. So it's like activation energy. What is carbon breaks down?
What?
What if carbon breaks down in activation energy? What if do we have CO2?
Sure. Yes. I mean, well, this is a hydrocarbon burning. This is called a combustion reaction, is what this is. This
Yeah.
is combustion.
But what if do we have carbon dioxide?
CO2 comes from combusting. You also get water. Yeah. That's why if you ever notice cars, you'll notice that, like, there's liquid dripping out of the exhaust pipe. It's because it's combustion. Okay. Let me help
Okay.
Shantrix with his question.
My man.
But I hope that helped you out, Jaden. Yeah, that's good. Cool. Okay, nice.
Well done.
All right, yeah, let's do yours, Shantrix. Okay, the lines with the equations y equals mx plus 7, y equals 2, x equals 0, y equals 0 form a trapezoid base area 3. If m is greater than 0, what is the value of m? Cool. I like this. What's up, Reki? Reki, how's life, dude? I haven't seen you in a bit. Well, I see you on the streams. You haven't asked a question, Reki. Reki just here redeeming bond coins. Okay, all right, that's fine. You can always redeem bond coins. All right, that's x equals 0. This is y equals 0. And then we have y equals 2. And then we have y equals mx plus 7. And m has to be greater than 0? Wait, what? Well, this is weird, man. Wait. mx plus 7. So that's gonna be like up here. And that's gonna be something like this. How does this form a trapezoid? Is the trapezoid in the room with us right now? Oh, the trapezoid's to the left. This is the trapezoid? That's kind of silly. Okay, fine. Yeah, I got you. Okay, fine. Usually in math, when we say that it's bounded by x equals 0, y equals 0, we usually mean it's bounded in this quadrant. We usually don't say anything's over here. When you do, like, calculus and stuff, you'll see that. Okay. Area of a trapezoid. Let me think. Is it like 1/2 base 1 plus base 2 times the height? Is that what it is? Yeah, good. And we know the height of this trapezoid, right? The height of this trapezoid is 2, right? This is always going to be a 2 height. Okay. So then the question is base 1, base 2. So, base 1 is going to be here, right? It's going to be the it's going to be the x coordinate. It's going to be the negative x coordinate here where this thing intersects. So and that's where, like, y equals 0. So I can just set this equal to 0. I can say 0 is equal to mx plus 7. Yeah, basically solve for y equals 0. But then take the negative, right? So you get negative 7 over m is equal to x. Right, but you see how that's negative x? So I want to make that positive. So I'm going to say that base 1 is equal to 7 over m. And then this one is going to be 2 is equal to mx plus 7. So negative 5 is equal to mx. So x is equal to... So base 2 is equal to 5 over m. Okay, cool. So then let's plug this into here. Area of the trapezoid needs to be 3. So I'll say 3 is equal to 1/2. And that's 7 over m plus 5 over m. All times 2. 2's cancel. What's up, Negro? Oh. Your fucking username, dog. I haven't seen that one before. Negro. Damn. Got me. He got me, dude. No. Don't cancel me, please. That's literally his username. Dr. Gold getting canceled now. I'm amazed they allow you to have that username. Usually they're pretty good at, like, canceling that, no? Alright, whatever. So this is 3 is equal to 7 over m plus 5 over m, so that's 12 over m. Oh, 12 over m. So then 3m is equal to 12. So then m is equal to 4. Is the answer equal to 4, Shantrix? Is that a 4? You got a 4 for this one? Yes, nice, cool, we did it.
Well done! Well done!
All right, what's up, Equity? We'll finish out with some chemistry today. This looks fun. Equita. All right, let's see. While I wait for Equity to come around, and we'll do his chemistry. See if we have any other fun ones I got. Did anybody submit any soccer mom questions for me to do yesterday? This was a brain teaser. Is this what you said? There's a brain teaser here. What am I supposed to do here, by the way? Am I supposed to figure out, like, how this works? You have to use order of operations to make each statement true. What? What do you mean? Like 0. Okay. But how do I get 0, 0, 0 to equal to 6? Okay, yeah, this one's easy. Okay, cool. This one's alright. I can do this. Okay, so then this is 3 times 3 minus 3. Because that's going to be 9 minus 3 is equal to 6. This is cool. I know this one. 5 divided by 5 is 1. And 1 plus 5 is equal to 6. Okay, cool. 6 minus 6 plus 6? 8 to the 8 divided by 8? No, no, that's wrong. 7 minus 7 divided by 7. That's a good one. Cool. I like that. This one's going to be interesting. I think... Is 0 to 0 equal to 1? No, right? 0 to 0 is undefined, I think, right? No, oh, 0 to 0 is 1. Oh, okay. I didn't realize that. How are we gonna get this last one though? You can use brackets and exponents too. Oh, okay. Damn. I think we got the easy ones out of the way, right? But I can't use any more numbers, right, Chantrix? Good to see you, Jaden. Good luck on your stuff, man. No more numbers, only operations. It could be a trick question. All right, what's up, Equity? Here, you want to help with your stuff? We got a lot of these done. We'll try to do these other ones next. Let's see what Equity wanted help with. Okay. One of the reactions used in the smelting of copper ores to produce copper and sulfur dioxide involves reacting copper 1 oxide with copper 1 sulfide. It's just a regression for the previous problem. Oh, did you? I just did my final in both math and physics and got a B and C. Nice, dude. That's passing.
That's dope.
Let us help you out with physics for next time, though. You should be able to get a B in physics. You know, I mean, I'm happy you passed, at least with a C, but you should be able to get a B. All right, let's balance this bitch. 2 coppers, 2 coppers. So I need at least 4 over here. But before I do that, so here's a little trick, Equity. Whenever you're balancing equations, if you have anything by itself, balance that part last, because that you get like freedom to like move around with that. So I notice I have 2 oxygens here. That means I'm probably going to need 2 oxygens here. Okay, so 2 oxygens, 2 oxygens, a sulfur. Now I have 4 plus 2. I have 6 coppers, so I'm going to put 6 over here. Yeah. Notice how I balanced this last. It's just kind of the easier thing to do. I found you after I needed help in physics. I do have a problem, though. Okay, submit it. You know where to submit it, Sebastian. We'll do it. Determine the limiting reagent. Okay. So, we have to do... And then I always like to look at like what we're trying to figure out. So eventually we're trying to figure out the amount of copper. So I'm going to say how much copper is equal to starting out with this amount. So 250,000 grams of Cu2O. And then I'm also going to do how much copper could I get with 129,000 Cu2O. Or not Cu2O, sorry. Cu2S. That's the difference. God damn it. Okay. And then whichever one is the least, that's the reaction that happens. And that's the limiting reactant. So I need masses for these things. 143.09. I'm just say 143 grams. And then you got to do a mole ratio here, right? So you got 2 moles of Cu2O to every 6 moles of Cu. And then let's get Cu2S. $159. And then the same thing. 6 moles of Cu, but now this is to 1 mole of Cu2S. So all that's left to do is run that calculator through it. So if we have 250,000 divided by 143 times 6 divided by 2, so times 3. I get that. If I do the other one, 129,000 divided by 159 times 6, I get 4867. So this one is limiting. So that's going to be Cu2S. And that got us 4,867 moles. Which, if I want to figure out how many grams of carbon that is, right? So then I say like 1 mole of Cu. And what is the mass of molar mass of Cu is no just Cu, not copper sulfide. 63.5. Okay, so we can multiply that by 63.5. And that gets me a really big number, which I'm going to divide by 1,000 to get kilograms. So 309.1 kilograms. But I only got 285, okay? So percent yield is going to be the amount I got in the experiment divided by the amount theoretically that I should have gotten just from the math. So that's going to be 285 over 309.1. And that's going to get me 0.92, so this is going to be about 92%.
My man.
Cool. Does that make sense, Equity? Yeah? Are you able to do second-order differential equation questions? Maybe. If you submit it to me using, use that website link down there, actualdiscord.com/submit, I can take a look at it. If not, I can always run it through ChatGPT and explain it to you. Help you understand it. I can always do that. How long will you take for me to get to my question? It's 1 a.m. Send it, and I'll do it in the next 5 minutes. Is that cool? Nice. Because I'm just wrapping up a chemistry question with another student real quick. All right, here we go. 50 liters of gas, 42 degrees centigrade, and 87 kPa. Calculate the temperature required to change the volume to 50 to 47. Okay, well, this is just PV is... Okay, so you have PV is equal to nRT, or P1V1 equals N1R1T1, which you can always move this over. And this gets you that PV over nRT is equal to 1. So P1V1 over N1R1T1 is also equal to P2V2 over NR2T2. Centigrade Celsius, it's the same thing. But yes, also, so when you're doing this, the R's are the same, right? And also the number of moles should be the same. We should not be changing the amount of gas that's there. So the N's and the R's are going to cancel. And now you just got to do stuff. Well, this is fucking gross because they put things in different units. Okay. So I'm going to put things in atmospheres, which means I'm going to do 87 over 101.3. That's going to get me atmospheres. And then I'm going to do 770 over 760, which is also going to get me atmospheres. 760 millimeters of mercury is 1 atmosphere, and 101.3 kPa is 1 atmosphere as well. So combined gas law. Yeah, just full gas law. So then you have... So you have 87 over 101.3 times the volume of 50 liters over 42 degrees. You need to convert that into Kelvin. So 42 plus 273 is going to be, what was that, 315? And then this is equal to 77 over 76 times 42.5 all over x. So this is just doing some math. 87 divided by 101.3 times 50 divided by 315 divided by 42.5 and then divided by 77 divided by 76. And then raise that to the -1 power to get x. We get 315.86. That's so different. So different. Did someone say doing some math? What's up, math major? We are doing some math. We did some chemistry. Okay, so yeah, the temperature required is that, which minus 273. I don't know. 42.86 degrees. It's not very much higher. Someone's gonna yell at me that I didn't use 237.15 or something for Kelvin, but whatever. So not very different. Okay. And then last little one here. Waiting for the second order differential equation to come up. Phantom says solve the sequence. X of n is x1 equals 5, x of n plus 1. Hey, let me just write this one down for him real quick. So I just have it. I see your question here, Phantom. It's first order, not second. Okay. Ooh, this is physics. One second, it's uploading. It's a big image, apparently. Still uploading. Bum, bum, bum. I should really just like screenshot these is what I should do. Alright, whatever. I am gonna do that. One second, I'm gonna cancel it. Oh, it got it. Okay, here it is. Yeah, look at this. I can like see into like this is so high resolution, dude. One second. Let me get this. Let me get a more decent size of this one. Let me just resize this. Cool. There we go. That's much better. Let me see equity real quick. Sketch the following. I think you just plug values in, right? X is just between -2 and -3. This is weird though. Oh, this is cool. Watch this. So you can look at this. F of 2 gets you 3 times 1/2 to the 1/3 times 2, so that's 2/3 minus 2/3. This is 0. This is 1. So you have f of 2 is equal to 3. That's just a good like first point to have. So 1, 2, 1, 2, 3. Cool. And it's increasing. So it should look something like this. I'm guessing. It's increasing. Yeah, that's an increasing rate, right? Yeah. It's probably something like this, But yeah, just plug in some values. That's what it should be. Yeah, it does look like there's some transformations. What is the horizontal asymptote? So that's the limit as x goes to infinity, which is infinity. There is no horizontal asymptote. Well, wait a minute. There is. I take that back because it's 1/2 to the infinity. Haha. Okay. Limit as x approaches infinity of 3 times 1/2 to the infinity. This is 0. So actually this is equal to 0. The horizontal asymptote's at 0, but you're not going to see that going from -2 to 3. And it should be decaying. Thank you, Math Major. Math Major is correct here, actually. Sorry. I forgot to check that the ratio here is a fraction. So in reality, it should be doing something like this. Yes, Google account. Is this your question? Yeah, you're good, dude. Okay. A particle of mass m moves through a rough horizontal table. P is attracted towards a fixed point O by a force of magnitude, blah, blah, blah. Coefficient of friction. Cool. This is all physics. I like this. Interesting that the force is proportional to 1 over x squared. Oh, yeah, that means it... Oh, yeah, this is electrostatics. This is cool. This comes from this, by the way. F is equal to k QQ over r squared. This is this would be like an electrostatic force. That's where I see the 1 over x squared from. Okay. Okay. So here's the key thing we have to show here. Okay, yeah, you're good. Okay. The force is this, and it's a restoring force, right? Did we say it was a restoring force? Yeah. So I'm going to say F is equal to negative K mg over x squared. Okay, because the further something gets away... Oh, I see. Well, yeah, no, but the force should be trying to bring it back, right? Yeah. This sign thing's actually kind of weird because it's x squared. If it's to the left and to the right, that's not gonna like change. I want the direction to change. But okay, let's just do it this way. Okay, so F equals this, and then F is also equal to MA, and MA is equal to dV dt. Right? Oh, but there is friction as well. Aren't all tables horizontal? How else would you eat off them? Okay, so here's the cool thing. So the force is trying to pull it to the left. Here's what I'm considering. Let me draw a little picture for this. So this is the origin O, right? And we have a particle P of mass m. So this is mass m. And it's moving, and it's attracted towards this, right? So that this means this is my force of attraction, where x is the distance to OP. Okay. The coefficient of friction is equal to mu. So if this thing is being... Well, okay, let's say P is initially projected in a direction away from O. The velocity of P is first 0 at a point A, which is a distance A from O. Okay, so there's a couple things going on here. So... Okay, so we're going to call this is X. This is the axis. This is X. And we say that when the mass is a distance A, it has a velocity equal to 0. Okay? Okay. And it's initially projected in a direction... Oh. I think I see what's happening here. Gotcha. No, I think I see what's happening here. Here's what... So, this thing here, right, is always being tried to be attracted right here. So, it's being flung to the right. And then as it's flung, it eventually stops at some coordinate A, okay? I wonder if we can use conservation of energy here. This is equal to some coordinate A, right? And then this is where Yeah. This is where v is equal to 0, okay? But then let's say here, for instance, at some point p, right? It has a velocity v which is not equal to 0. Okay. So, as this thing is moving to the left, okay? It's going to experience a force of friction trying to pull it back. Sorry, it's going to experience this attractive force trying to pull it back, but it's also going to experience a force of friction which is in the negative direction of the velocity. So if the thing is moving this way, friction will pull it back to the left. Friction opposes motion. So this is force of friction, okay? And what we learn about force of friction is that's equal to mu k Fn, which normal force is usually equal to mg, so this is equal to mu mg. Okay? So at P, so let's say this is like at point P, you have negative k over mg x squared. R is equal to... Wait, where the fuck are you getting R? One second. So it's this, and then it's minus mu mg. Right? This is where it is at... This is the total... This is F total. Okay? In the case that it's moving... And that's if this thing is moving this way. And this is cool. Eventually we're going to show that... I think once this thing has moved all the way over here, that all of this will have added to 0. Correct. It does change to static from... Yeah, good to see you, Mizan. It does change from kinetic to static for a second. Correct. Okay, so I think this is your F net. And then this is equal to... So the fact they have ddx of v squared here, this makes me think we're doing energy. The reason why I say this is that because kinetic energy is equal to 1/2 mv squared. I'm thinking we're going to have to do this. I think you have to do conservation of energy. Because what we're saying is that if the velocity is here, the velocity is 0 here, then your potential is equal to 0. Sorry, your potential is maximum, your kinetic is 0. Are you sure you're not using conservation of energy? Okay, let's just try to solve it though. So F is equal to ma, so that's m dv dt is equal to negative k mg over x squared minus mu mg, okay? That's when it's moving away from O. I'm going to say to the right, so the m's are going to cancel. So now I have dv dt is equal to negative kg over x squared minus mu g. So let's see what they're doing here. Oh, that's the squeeze theorem, I think. Oh, wait. Cosine? Well, that's 0. No, that's just 0. So dv dt is equal plus kg over x squared plus mu g is equal to 0. They want to do ddx of v squared? Why not ddt? Why are we're not doing any ddt here? Okay. I think we have to do conservation of energy. I do think. I don't think like kinematics here works because I have no DDTs. Right? Unless your teacher's making a mistake. Okay, but let's try to do it the other way. R is the reaction force. You just call it something different? Yeah, that's just the net force, right? One sec. I also threw this at ChatGPT at one point just to see what was happening. Where did I do it? Yeah, it's work. Yeah, we got to do work energy. Yep. It's got to be, yep. We're doing conservation of energy. Uh-oh. I'm going to show you how this works. It's kind of cool, actually. Hey, Dr. G, I saw your live stream. I just want to say hi. What's up, Brianna? This is like some advanced physics. This is, you remember when I was telling you that our physics class is not calculus-based? This is a calculus-based physics class. Even more, like, fucked, this is a differential equations-based physics class. But it's the same shit you learned, Priyana, when we were in class. So here's the key thing here. It's that the change in kinetic energy, which is equal to, right, delta 1/2 mv squared. That's also equal to the net work being done on an object. And the net work being done on an object is equal to, we would say force times distance. The problem here is that the force varies as a function of the distance. So this is equal to integral of f dx. Yeah, I think this is the way you got to do it. Yeah, you can't... Well, you do need to use forces. Forces need to show up here. But you have to do... This is work energy, is what you have to do. So you have to do the net work being done on the object. So you have work being done by friction, and you have work being done by the restoring force. And those things combined need to change out the kinetic energy. Which, very cool here, they tell us that the velocity is 0 at point A. So this is the change in kinetic energy. You go from something moving very, very quickly to something not moving at all. Yeah, the question is in dvdx. No, we'll get to that. Do you notice how nothing here is ddt yet? This is dx. And then this is going to be dv. I'll show you. I'll show you where it comes from. Yeah. Okay. So, what we want to say is that, so, delta work, which is equal to dw, that's equal to f dx, okay? Delta kinetic energy, which is equal to, like, dke, is equal to d, and then we say 1/2 mv squared, okay? Does that make sense so far? Well, watch. Okay, so if I do this, this is 1/2 m d v squared is equal to f net dx. Okay, and then f net was this, right? It's the force. It's the restoring force and the force of friction. So you have 1/2 m d v squared is equal to this dx. So now I can cancel out the m's. I can multiply through by 2, and I get 2 dv squared is equal to negative 2kg over x squared minus 2 mu g. And then dx. And then you can move the dx over. So then I have d v squared dx is equal to negative 2 kg over x squared minus 2 mu g. Chrissy says, oh, here I am barely knowing college algebra, setting off a mathematics major, and this is all Greek to me. Okay, no, it's cool. And yeah, look, when you rearrange this, bro, do you see this? See how you get dv squared dx plus 2 kg over x squared plus 2 mu g equals 0? That's the right answer. This is kind of dude, this is mean, bro. This is mean that if this is a math class, they gave this to you. This isn't pure math. You need to know physics in order to do this. You have to know, this is the work energy theorem. You have to know specifically that this is true. And this does not come from math. I don't think it does. Right? Anyways, that's cool. So, this is the math part now, because now they say verify that this is true. So, I mean, to verify, you just take the derivative of this with respect to x, right? Am I crazy for taking trig and pre-calc alongside? No, not at all. Sorry. Trig and pre-calc is the same thing. Yeah. Like, pre-calc includes trig. Google Count says, how do you know the velocity at the start? You don't. You just know that the change in the velocity, right? The change in the velocity squared is proportional to the amount of work that is done, which is the integral of f dx. So if you derive both sides, right? Derivative of an integral gets rid of that. Then you get like f dx is equal to d this. If you wanted to figure out what the velocity was at the beginning, you can do conservation of energy, which is that, so at the beginning here, you have 1/2 mv squared, and then at the end here, you have 0, and then you have plus the net work, which is equal to the integral of this thing, dx, from 0 to point A. Oh, very cool. Oh, I think I see. That's how we're going to get this, bro. Do you see this? So, okay. So, delta KE, right? So, this is KE final minus KE initial. Your final kinetic energy is 0. Okay? Because we say at point A, once this thing is moved to the right, it has no more velocity. But at the beginning, it had to have some initial velocity, which, whatever. We say it starts moving at a velocity v. I think they do, right? Is that what they say? Oh, no. Oh, I see. V is the velocity of P. But where is P? But what distance is P at? Okay. I guess that's when x equals 0. This is at x equals 0. Cool. So at x equals 0, this has a velocity v, or like I'm gonna call this like v naught, and you haven't lost any energy to friction. You haven't lost any energy to the restoring force yet. So your initial kinetic energy here is 1/2 mv naught squared. And then after this thing moves to point A and it stops, now you've lost all of this kinetic energy, right? So you have this is the amount that you lost, is equal to the integral of this. It's equal to the net work that was done, which is negative. So it's actually negative negative, so whatever. Fuck it. Just make it positive, right? Bro, we're back. We're so back. Okay. Okay, so I think like all these negatives just go away. So it's the integral of this dx. What's good, Darren, dude? Yeah, we're doing like, dude, look at this. This is also what you guys were doing, like work energy, kinetic energy and shit. But this is when we start involving calculus. This is with a force that depends on the distance squared. It's like it's not even a spring. It's like some super goofy electric spring or something. Okay. All right. Okay, so if I integrate this integral, so this is kmg integral from 0 to a of 1 over x squared. And then I'm going to say plus mu mg integral of dx from 0 to a, right? And so integral of 1 over x squared is negative 1 over x. So I'm going to get kmg negative 1 over x from 0 to a. And I'm going to say plus mu mg times x from 0 to a is equal to 1/2 m v naught squared. Yeah, now I see where this is kind of messing up. Well, okay, here's the cool thing. Yes, it's the change in kinetic energy where technically my energy final is always 0. Doctor, how'd you get so smart? Do you just love to study, or are you one that just didn't have to study very much? In middle school and high school, yeah, I was just like kind of naturally gifted at math. So I didn't really have to work so hard. College, I got like fucked. Like things started getting difficult. But luckily I had a work ethic from doing other things. So no, I'm not particularly like, I don't think I'm like really that smart. I'm very perseverant. I don't give up. So I think that's the most important thing. Don't worry if like those kids who are like fucking savants and like geniuses in your class and everything, man, they always burn out because like they may be naturally smart, but they lack the work ethic and the perseverance and also probably the enjoyment for life to keep going. I got humbled in Calc 3, had the biggest ego before that. Yeah, my biggest ego, my ego hit when I hit the wall, Mizan, was when it was quantum mechanics in grad school. Yeah, I just could not get it for any. I was like, fuck, I don't understand this. Okay, here's a very cool thing though. Here's a very, very, very cool thing that I want to show. Google account, whatever his name is, Google account. Okay, your kinetic energy final is 0. Your kinetic energy initial is 1/2 mv squared, and that's equal to the net work that's done from 0 to x of f dx. Okay. So instead of going from like 0 to a in terms of position, I'm going to go from x to a. And now this is not v naught squared. This is just v squared. Now this is super dope because now this is 1/2 mv squared. Oh, so all the m's fucking cancel. Get rid of all the fucking m's. Bye. So now I get 1/2 v squared is equal to kg, and then this is going to be 1 over, it's negative 1 over a minus 1 over x, so I'm going to say it's 1 over x minus 1 over a, and then that's plus mu g a minus x. Is that what the right answer was? Oh, and then we got to multiply this fucking 2. Multiply the 2 in. Very cool. So now you get that v squared is equal to 2 kg 1 over x minus 1 over a plus 2 mu g a minus x. Oh, look at that. That's fucking gorgeous, dude. Look, it's the same fucking thing. Hell yeah, dude. Oh, I'm so happy, dude. This is such a brutal question, dude. This is not math. Not math. This is a physics question. How do you get part A? How do you do this? I did that here. Yeah. Well, did I do it here? No. Where did I do it? I did it here. Yeah. So here's the main thing. Yeah, okay. Okay. Let me explain it like simply. Work is equal to the integral of f dx. This is a physics thing we learn, okay? So the differential of work, so dw is equal to differential of an integral. Differential of an integral kills each other. So I say dw is equal to f dx, okay? Now, the other thing I learn is that work, or like, I want to think how I want to explain this. D net work is equal to D like 1/2 mv squared. It's really this. It's dke, which is equal to D 1/2 mv squared. This is kinetic energy. This is kind of how we learn this. So delta work is equal to delta ke. So this is the same thing as saying dw is equal to dke. And then this is, right, this is 1/2 mv squared, mv final squared minus 1/2 mv initial squared, or whatever. But it's the same thing as delta 1/2 mv squared. So now I say that this, right, d 1/2 mv squared is equal to dw, which is equal to f dx. So I have 1/2 m dv squared is equal to f net dx, and f net was this. And then all you gotta do is just run the dx over. What's up, AFG? Make sense? Cool. Very cool question, dude. I really enjoyed that one. This is not a differential. I know this looks like it's a differential equation, because I mean it does have derivatives, but this was this for a math class, dude? This is really cruel if this is for a math class. This is not a math class. This is a physics class, and I would say it's an advanced physics class. He did it by solving a differential equation. Yeah. Well, I mean, here's what he did. So, okay. Yeah, you could cheat. You want to see how to cheat? But this isn't even like cool. So, in math, sometimes when they say like verify, they just mean just plug that shit in. So, he wanted to show that d dx of this satisfied this equation, which, yeah. So if you do d dx of v squared, you get, right, this is a constant, this goes away, this goes away, and so you get negative 2gk over x squared minus 2 mu g, right? That's what this is. And then you should see that when you plug that in for here, this cancels with this. And this cancels with this. And then you just get 0. Like, yes. I mean, that's technically correct. He actually solved it. He used separation of variables. Oh, for this. Oh, he actually solved this. Okay. Let's see. You probably could too. Let me see. You need everything with x on one side, right? Oh. Yeah, okay, so you get d dx of v squared is equal to negative 2kg over x squared minus 2 mu g. Move the dx over, so you get dv squared is equal to negative 2kg over x squared minus 2 mu g. And then this is all dx. I get it. And then you integrate this, right? Integrate. This is v squared. And you're integrating from some velocity v to a velocity 0. And the velocity v happened at some position x to some final position a, right? You see how your velocity was 0 at position a, and your velocity is v at some position at x. Yeah, you can send in the office hours channel if you want. Yeah, that's fine. There's a thing called help screenshots. That's probably the easiest way to get help. So, okay, now when you integrate this, you get the same thing, right? It should be negative v squared. Did I fuck that up? Oh, v is at the bottom? Well, it doesn't really matter anyways, right? Because it's v squared. It's just going to go away anyways. Why would we say negative v? I think it's... No, it's v is equal to 0 because it's moving to the right first. Right? We have that it's moving with some velocity equals to v. And then at some position x. And then eventually when its position is equal to a, the velocity is 0. I think. So I can also just... I can just flip this, right? Just to make things nicer. Because then that's 2 kg. Oh, but it's minus, and then it's 1 over x minus 1 over a. And then it's plus 2 mu g x minus a. And I think that's the same answer they got. Yeah, well, they got a minus x, so there's another minus sign somewhere that I messed up, but... Yeah, maybe there is a minus here, maybe. Okay, anyways, it's the same thing. Cool. This was a math class question, but it's like the hardest class before university, which I think is called College in America. Yeah. What country are you from, Google account? Where are you from, dog? Where you reside? UK, brother. Cool. Was this A-levels then? A-levels, O-levels or something? Definitely not GCSE. It'd be a little fucking hard for GCSE, right? A-levels. Cool, man. It's a good question. It's hard, man, dude. That would stump a lot of college kids. That would stump all of the students in my my UCLA physics class. I would tell you just straight up. They would see that. They would tell me, "No, Dr. Gold, like you're not allowed to ask us that." And I would agree because that's a hard question. Okay. But yeah, good luck with everything. If you ever have questions, man, here, if you want to figure out when else we stream, we have a whole calendar, which here, I'll put in the chat here real quick. So I stream like 3 times a week, and there's the schedule if you ever want to figure out. If you have other math questions, we have some other really cool friends that stream math, like, so Zach here, E to the 2i Pi, on Saturday morning, which I think is friendlier for you, right? That's probably like Saturday afternoon for you. He has a math chat where you can just ask him whatever math questions. He'll go over them as well. He's a math professor. But check it out. AFG says, have you played Red Dead Redemption 2? I haven't played any of the Red Deads, honestly. Have not. All right, let's see. Hatem has this question. Change the following. I can do chemistry. Yes. I can do stats. Yeah, chem and stats. I can do both of those. I love chem. I was just doing chem earlier. I mean, this is easy. This is like baby chem, but where was it? Yeah, we did this earlier. This was limiting reactants. This is kind of chemistry, right? I've done some other chemistry stuff before. I don't know. Like, this is decibels or something. I don't know. Whatever. We do a bunch of stuff. It's like a STEM playground, doing stuff. Yeah, have a great day, dude. You're good, dude. Enjoy. Alright, this looks like a pain in the ass. Change the following double integral into polar. Do not evaluate. Okay. Well, what I know for polar conversion, right, is that dx dy turns into r dr d theta. I know x goes into r cosine theta. Y goes into r sine theta. This is Cartesian to polar. And then x squared plus y squared is equal to r squared, right? So, this is the integral of r sine theta. So I'm changing y to r sine theta. And then it's ln of x squared plus y squared, which is just r squared. So I'm going to say ln of r squared. And then this is r dr d theta. Okay, now we got to fuck with the bounds. So this is in terms of y. So y is going from 1 to 2, which means that 1 equals r sine theta, and then 2 equals r sine theta. I don't really like that. Uh-oh. What class? Yeah, theta 1, theta 2, thank you. Yeah, you have to sketch. Yeah, you're right. I do gotta sketch this bitch. Okay, fine. No, you're okay. Yeah, delta, theta, all this stuff. This stuff comes in calculus. Yahoo account says, do you think you're better than me, Google account?
Oh, no.
God, you guys are trolling now. Okay, alright, so this tells me dy goes from 0 to 2. Right? Okay. So I know, at least for my bounds here, we're going somewhere from here to here, right? Okay. Now I can figure out what x is doing. So x goes from 0 to the square root of y squared minus 2y minus y squared. So we go from x equals 0 to x is equal to the square root of 2y minus y squared. So I can rearrange this, right? That means x squared is equal to 2y minus y squared. Oh, this is fucking ugly. Oh, it's 1 to 2? Oh, you're right. It is 1 to 2. My bad. Thank you, Jeff. You get a save for that. Yeah, okay, so how do I determine where x goes from? X is going to go from 0 to the square root of 2y minus y squared? What is, like, what the fuck is this? Do I plug in the different values for y? Complete the square for y and you get a circle? No way. Are you serious? Okay. X squared plus y squared minus 2y equals 0. Okay. Okay, so this is x squared plus y squared minus 2y plus 1 plus 1. Oh, that's fucking cute. X squared plus y minus 1 squared equals 1. Oh, that's so cute. This is a circle at 0, 1 with radius 1. Okay, cool. Oh, look. Okay, so it's right here. So, yeah, okay, cool. So it's gonna, like, do this. Right, because that's all I care about, yeah? Oh, 0, 1.5? Oh, yeah, sorry, my bad. I'm getting tired. We're hitting the 2-hour mark. My bad. Sorry. I apologize. Okay, there we go. Yes. Thank you, Jeff. There we go. Okay. So it's going from here to here. Which, cool. That's a quarter of a circle. Okay, so now I automatically know what's happening. Okay. So now, our bounds in terms of dr is going to be from 0 to 1. The radius is 1. And then d theta is going to be... oh, yo, what's up, Don? Don, you've been streaming for a fucking while, dude. What? Don, I caught you, bro, on at like 2 o'clock when I was like taking a nap. It's like 6 now. What? Don's been streaming for a while. Oh. Actually, no, I'm wrong. It's not from 0 to 1. Sorry, my bizzles. Good, man. I agree 0 to... No, well, wait. So, wait. I don't really... man, I don't think 0 to 90 is theta. I don't think so. Right, because this is going to be at 1, 1. So, I think we're going from this angle, which is going to be pi over 4, all the way up to here, which is 90. So, d theta actually goes from pi over 4 to pi over 2. And then r, right? Because we have to think when we're integrating polar coordinates, we're doing stuff from the origin. So this is my area that I'm dealing with, right? He says r is 1. I don't think r is 1. Because r is definitely not 1 here. It's the square root of 2. R is a function of theta. Right? What's the curve? Let's see, Hamiltonian. This is it. 7. What's up, Fanbox? Yeah, so what we did here is we converted this for x into using, completing the square. And we got the equation for a circle, which is offset up by 1 and has a radius of 1. And so I think so dy is being measured from 1 to 2. So my x is then being measured from here out to here. You got to get the circle equation in terms of r. Oh, no. Fine. Okay, let's just do it. Okay. So here, you want me to write this? So what? That's r squared cosine squared theta? Why not put another coordinate change to put the circle at the origin? I think he's right. No, you're okay, Descendant Fonts. I saw you at Don's. You're good, dude. Yeah, so okay, here's my question. Are you saying if I change this coordinate system down 1, but then I would need to change all references to y to be down 1 as well, right? This is a tricky one. Or let's think about it. Wait, whoa. Okay. I think we can solve this. Right, okay. First of all, if this is R, and then this is going to be, that's R sine theta, right? Which is going to start at 1.
Nice.
Actual Education's dad, good job, son. I'm proud of you. Thank you. Thank you, son. Thank you, dad. I don't know if this is actually my dad or like someone trolling me. You can also use r squared over 2 d theta. Are you saying? Well, here's my question. I don't think I want to rearrange this to solve for r. Do I? You do? Okay, fine. But you can't put x2 plus y2 equals r squared. Oh, he says. How do you nurture doctors in your family? That's so funny. Okay, whatever. Let's just do it. Let's just do it from here, right? So r squared cosine squared theta plus r. Okay. This is just r squared, right? X squared plus y squared is r squared. So I have r squared minus 2r sine theta. Is equal to 0 from here. Oh, I see. Okay. So then r times r minus 1 times r minus 2 sine theta is equal to 0. Okay. So you get r is equal to 0 or r is equal to 2 sine theta. So interesting. But r equals 0 doesn't make any sense to me, right? So I think I want this to be 2 sine theta. And then, but I want my lower bound for r. What's my lower bound for r going to be?
Nice.
Wow, thanks for the follow, dude. Me and your dad are... Oh, dude, now I have Actual Education's mom? Wow. My mom and my dad here. It's a straight line. Oh, it is a straight line. Oh, okay. Sorry, that's r outer, right? R inner is going to be this one, and that's y equals 1. So that's r sine theta equals 1. So r is equal to 1 over the sine theta. Oh, very cool. So this is just 1 over sine theta. Damn, get some bad news on the stream here. Oh, God. It's real sad, dude. Okay, I think this is correct. All right, so I think this is our final answer. Final answer. That's pretty cool, actually. I get it now. Okay, I get it. The 2 sine theta, that describes the equation of this. This is the r outer, and then r inner describes this straight line, which is just y equals 1. Oh, very cool. That makes sense. Yay, we love sense. Nice. Cool. That was a cool question. I appreciate it. That was dope. Let's see. Do we have any other ones? I do have to run to a birthday dinner pretty soon here. Son, who is Sense? Why do you love her? She pays my rent.
That's dope.
Okay. I don't think we have any other questions yet. Let me give a shout out to Don, though. Yeah, you should really be following. Don's another awesome friend of ours. Don Factorial these days. The rebrand is dope. So if you want to also get free help with math and stuff, and he does like some physics. You were doing like special relativity at one point, weren't you doing? That's pretty fun stuff. Yeah. Okay, I gotta run to dinner, but let's close out the stream. Appreciate everyone being here, and let's go. All right, cool. Thank you everyone for coming to Actual Education Office Hours today. I appreciate all the questions we had. Again, we will be streaming tomorrow, starting at 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Come on by. Yes, I would love to. Yeah, if you're doing GR stuff, that'd be pretty fun to. I always love seeing it, dude. Special relativity and GR stuff like it gives me nightmares. Thank you for fighting poverty and inequality with your education. I appreciate that, Dissident Fonts. Let's go raid somebody. Oh, AFG, you and Meezen are playing chess. Cool. Show me the game. We used to have chess tournaments in the server. Maybe we should more often. Let's see, who we're gonna go raid. Let's go raid someone. Bum 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 bum. What we got? A game about Goat Boy. That's an interesting one. Okay. Nerduino is doing space and astronomy news. That's cool. And the corn stream. I don't know about the corn stream. Let's go see. Yeah, let's go say hi to Nerduino. He's a cool guy. All right, cool. I appreciate all space stuff. Space is dope. Okay. Cool. All right. Enjoy the rest of your Tuesday. Love seeing you guys. We will see you tomorrow. Peace.